Today we'll be doing 3.5, area of dilated figures. We're going to start with an original figure, and we're going to see how my area is affected if I have different scale factors, if I were to dilate the original figure. Okay, so if we're dilating an original figure, making it bigger or making it smaller, we're going to see how area is affected in all of this. Okay, let's start with finding out the area of this original figure, which is a rectangle. So let me get my pen ready. This is a rectangle. And because it's a rectangle, my formula for a rectangle is area, A, equals length times your width. You're multiplying the length and the width. Well, my length, L, is 5 feet, and my W, my width, is 2 feet. Okay, so let's find out the area. Area equals 5 times 2. Okay, so 5, which is a length, multiplied by 2, which is a width. If I use my calculator, and let's bring it in. If I do 5 times 2, if I'm multiplying, I get 10. All right, so my area equals 10. Because we're talking about area, and this is in feet, I'll write feet squared. So the squared goes if I'm talking about area. So this is my area of this rectangle. Okay, right below we have a little table here that we'll be using today. It says, well, if the original rectangle is 5 feet by 2 feet, and it says base, but in other words, they're talking about the length. And so in this formula, it says base times height. In other words, it's A equals length times width. Okay, same thing. It just looks a little different. Okay, but base, they're talking about length. Okay, so my area would be 10 feet squared, right? We just figured this out for 5 feet and 2 feet. If I look, it says base, it's same thing as length, and my height would be the same thing as my width. So let's write that down. Okay, so they say base, which means length. They say height, which is width. And they say for a rectangle, it's area equals base times height, which is the same thing. Area equals length times width. We're still multiplying both of those numbers. So don't let that confuse you. They're just using different words to mean length and width. Okay, so what if I have a scale factor, SF, of 2? Well, if the scale factor is 2, it means my rectangle is getting bigger, okay? So it means that my sides are going to double because my scale factor is doubling everything, okay? So it says, well, the base or the length for a scale factor of 2 is 10 feet. Why? Because I'm doing 5 times 2, and that's how I'm getting that 10. So to get my height or my width, I would have to grab 2, which is the original, and multiply it by 2, and I get 4 feet. So I'm just doubling whatever is we had for the original, for the length and the width. So 10 feet by 4 feet for the area, so length times width, is going to give you 40. And it's feet squared. Okay, so if I were to double the size of the original rectangle, What happens to the area? Well, the area now is 40 feet squared. If we compare the area from the original, which is 10 feet, and the area of the new figure, which is the scale factor of 2, it's 40 feet squared. What happened is that it got 4 times bigger. Okay, so look at the pattern. You doubled the length and the width, and your area resulted to be quadrupled from what the original area was. Okay, so just kind of notice that pattern, that we doubled the sides in size, and the area actually quadrupled. It got 4 times bigger. Instead of doubling, it got 4 times bigger. Okay, so what if I were to make this 3 times bigger? So what if the scale factor is 3 now? Well, my original is 5, right? And I'm going to multiply it by 3. And my length is now going to be 15 feet. In my rectangle, if I make everything 3 times bigger, my original was 2 feet. I multiply it by 3 and I get 6 feet. So I'll multiply 15 times 6 and get an answer. Which, if you go to your calculator and do 15 times 6, you should get 90. And it's feet squared. Okay, so look at this. I made everything 3 times bigger than we did the original. And my area is 9 times bigger than the original. Okay, so just take a moment and look at that. Okay, my scale factor is 3 and it got 9 times bigger for my area. Okay, so let's look. What if my scale factor is cut in half, or is 1/2? Okay, so I could take the 5 from the original and multiply it by 1/2, or I could grab 5 and divide it by 2, and we'll get the same answer. The answer should be 5/2 or 2.5. I'll just use the fraction here for this one. Okay, so it's getting half the size now than what it originally was. So we're cutting it in half. The scale factor is 1/2, which means everything is cutting in half for the sides. Now let's look at the side for the width or the height. The original is 2 feet, and I know I can multiply it by 1/2, or I can grab 2 and divide it by 2. Either way, I would get the same answer, which is 1. Okay, so if I do 5/2 multiplied by 1, your answer is 5/2, and it's feet squared. Okay, so multiply them in your calculator, you'll get the same thing here. I'm not going to do this part, just extra information. Okay, what is the reason that we're doing this? Why are we looking at the skill factor and comparing it with the area? Because we want to find a pattern here, okay? So that we don't have to do this every time, okay? Looking at the original and then looking at the skill factor and then multiplying the sides and then looking for the area. There's an easier way to do this with a formula, okay? So what if I have a skill factor and we call it x? Well, I know I have to multiply the original side, which is 5, so let's call it 5, and multiply it by whatever that x is, whatever that scale factor is. I have to take my width, which is 2, originally and multiply it by whatever x is. Okay, so I would have to get my area, I would have to multiply these two parts, right? 5x multiplied by 2x. When I work this out, I would get, 5 times 2 is 10. X and x is x squared. So what's happening is that you're grabbing this scale factor and you're actually squaring it. And that tells you how much bigger it's going to be from the original. Okay? So, how can the scale factor be used to predict the area of the new similar figure? You're going to square the scale factor and multiply by the original area. Okay, please take a moment and write that down. My area for any dilated figure will be grab the original area and then you're going to multiply it by whatever the scale factor SF is, and you're going to square the scale factor. So remember that when I say scaled figures, I'm talking about dilated figures. And I don't know how to spell today. So things are getting bigger or images are getting smaller. And if I ask for the area with this dilated figure, this is a formula that you're using. All right, I'm going to show you how to use this area formula for scaled figures in example 3. I see it says a figure is scaled up to create a new figure with a scale factor of 4. So my SF, my scale factor, is 4. It says if the area of the original figure is 22 square feet, what is the area of the new figure? Okay, so I want to find the area of the scaled figure. I'm going to write, SF is 4. The area of original figure, it's 22 feet squared, or squared feet. Okay, so the scale factor is 4. The original area is 22. Those are the two pieces of information I need to use the formula. So I'm going to write, A for area of the scaled figure equals, I know I need to do my original area first in the parentheses, and then in the other parentheses I fill in my scale factor and I square it. Okay, so let's kind of replace things. I'll leave 2 different blanks and then I'll write my square. The original area is 22. 22 goes first. The scale factor is 4, so it goes second. Okay, exactly how I see it, the parentheses with 22 and then the 4 with the parentheses in the square. I'm going to put it in my calculator and get an answer. Okay, so it's parenthesis 22, parenthesis 4, and then I'm going to square it. And then enter. 352. Okay, so my area of the scaled figure is 352 feet, and this is squared. So this area that we just looked for, that we figured out, is the area of the figure with a scale factor of 4. Ok, lo que estoy haciendo para ejemplo 2 y ejemplo 3, lo importante para que sepan para el día de hoy es la fórmula que estamos usando para sacar la área de figuras escaladas, figuras que se están haciendo más grandes o más pequeñas en tamaño. Okay. Tú necesitas dos piezas muy importantes para la fórmula. Tienes que saber cuál es la área original y cuál es el scale factor. Okay, eso son dos cosas que necesitan para usar la fórmula para figuras escaladas. En otras palabras, figuras dilatadas. Ok, para ejemplo 3, me dice que una figura está escalada para crear una nueva figura con un factor de 4. So, el scale factor es 4. Dice que la figura original tiene una área de 22 pies cuadrados. ¿Cuál es la área de la nueva figura escalada? Ok, entonces yo aquí en esta parte puse dos piezas importantes de información. So, el scale factor es 4, la área original es 22. Dos cosas que solamente necesito para buscar la área nueva de la figura escalada. So, A para la área de la figura escalada es igual a la original área multiplicada por el scale factor cuadrado. So, yo reemplacé. 22 va primero, luego va al 4 y está haciendo cuadrado ese 4. Lo puse exactamente como lo vi en la calculadora. 22 con las paréntesis, el 4 con las paréntesis y el cuadrito. Y me dio 352 pies cuadrados. Pongan sus unidades, por favor. Okay, so 4, 5, and 6, very similar in nature. I am looking for the new area. Okay, so let's see what piece of information I get for number 4. It says a figure is scaled up to create a new figure with a scale factor of 7. Okay, so it's telling you your scale factor right there, 7. If the area of the original figure is 30 feet squared, so area of original figure, it's 30 feet squared. What is the area of the new figure? Okay, so A for the area of the new figure equals, well, remember, we have two different blanks, and the second blank with parentheses has that square. All right, so at the top, I'm just going to write the formula so we can look at it and reference back. Scale factor goes second, and it's squared. All right, so in my first set of parentheses, I'm going to put the original figure area, which is 30 feet. So 30 goes first. 7 is my scale factor, so it goes in the second set of parentheses. Exactly how I see it, I'm going to put it in my calculator. So let's put it in parentheses 30, parentheses, 7, and then square it. Enter. 1,470. So my area equals 1,470, and put your units, please, so it's feet squared. All right, let's look at 5 and see what we have next. It says a figure is scaled up to create a new figure with a scale factor of 1/2. So my scale factor, SF, equals 1/2. It's a fraction. So that, to me, tells me that my figure is going to get smaller. So probably my area is going to be smaller than the original. It says if the area of the original is 50 square feet, what is the area of the new figure? Okay, so the area of original, it's 50 feet squared. I need to find the area of the new figure. I'll leave two spaces with blanks in it for my parentheses. The second set of parentheses has that square. Okay, so the original area should go first always, and it's 50. The scale factor goes in the second set of parentheses with that square. Okay, exactly how I see it, I'll put it in my calculator. So let's drag in our calculator over here. So, parenthesis 50, parenthesis, and I'm gonna put in a fraction. So alpha y equals 1 over 2, and then square it exactly how you see it in your paper. And it's 25 over 2. Oops. 25 over 2. So my area equals 25 over 2. And this is still in feet squared. Okay, so you could either get 25 over 2, or you could have gotten the decimal, which is 12.5 feet squared. Either one is correct. Just one is a fraction. The other one is decimal. I take both. Okay. The last one, it says, what is the area of a triangle with a base of 10 inches and height of 5 inches if it is dilated with a scale factor of 3? Okay, so first things first, the scale factor is 3. I need to figure out what is the area of the original figure. I don't know that. They didn't give it to me right off the bat this time. They did tell me, though, that the area of the triangle, so we're dealing with a triangle here. It says the base is 10. So I'll draw in my 10 in the base. My height is 5 inches. Okay, but they don't give me the original area. So I'm going to have to figure that one out. They want us to do a little bit more work. That's okay. Let's do the work. I know that for a triangle, the formula for an area is base times height, and we're going to divide it by 2. So they gave me the base, they gave me the height. I can figure this one out. Area equals, well, it's 10 multiplied by 5, and then we'll divide it by 2. Let's bring in my calculator. I'm going to put it exactly how I see it, this fraction. So it's going to be 10 times 5. We're multiplying. Oop, and it's 5, not 6. 10 times 5 over 2. Enter. And I get 25. Okay, so let's move this out of the way. So my original area is actually 25, and this is in inches, and it's squared. So my area of the original is 25 inches squared. Okay, I had to do a little bit of work in the other problems. They give it to me automatically. Here, I had to do a little bit more work. Okay, but I haven't answered the question, okay? And to use that formula that we have been using, so the area of the scaled figure equals the first set of parentheses, the second set of parentheses, and the square, right? So the first set of parentheses, we write down the area of the original, which is 25. In the second set of parentheses, we put the scale factor, which is 3. So area equals, well, let's look at our calculator here. So it's parenthesis 25 parenthesis 3 squared to 25 is what you should get. And this is inches squared. This is what I was looking for. Okay, so I'm just going to write a reminder here at the top. Remember that it's the original area first, then it's the scale factor that's being squared. So make sure you're using the correct formula for that one. I think you have homework in your computer this time, so pull out your computers, start doing some of the practice. Okay, good luck with that. All right, if you want to hear some instruction in Spanish for number 6, go ahead and you can listen, but if you want to go ahead and get started in the homework, go ahead and get started. Ok, voy a dar un poquito de instrucción para número 6 en español. Si quieren empezar su tarea, está bien, empiecen su tarea, enciendan las computadoras, pero si quieren escuchar un poquito más de cómo hice el número 6, pueden escuchar y después empezar su tarea, ¿ok? Número 6, dice que la área del triángulo tiene la base de 10 y la altura de 5. ¿Cuál es la área si es dilatada con un factor de 3? ¿Okay? So, hay dos cosas que yo voy a tener que buscar aquí. ¿Cuál es la área de la figura original? Y ya cuando encuentre esa parte, usar esa área para buscar la área de la figura escalada con un factor de 3. ¿Okay? So, yo sabía que el factor es 3. ¿Okay? So, yo sabía esta parte. Lo que no me dieron, como siempre, fue la área del original. Y eso es lo que busqué. Yo busqué este 25, ¿ok? Ustedes pueden ver mi trabajo acá al ladito. Ups, si puedo. Ahí está. Ustedes pueden ver cómo dibujé mi triángulo. Tuve que buscar la área de la figura original. No me la dieron, no fueron buenas gentes y no me dieron esa área como los otros ejemplos. Lo tuve que buscar en esta parte, ¿ok? So, acuérdense que un triángulo tiene una base y tiene una altura. La base me dijeron que era 10, la altura es 5. Usé mi fórmula para un triángulo que dice base por altura, divídelo entre 2. So, yo usé mi fórmula para la área de un triángulo. Yo reemplacé base y altura en mi fórmula. So, 10 por 5 dividido entre 2. Y mi área es 25. Y son pulgadas cuadradas. Ok, so mi área de la figura original de este triángulo es 25. Yo quiero y estoy buscando la área de este triángulo si es dilatado por un factor de 3. Si está siendo más grande, si está siendo enlargado por el factor de 3, ¿cuál sería la área? Esa es la pregunta. So, uso mi fórmula que estoy usando para los otros ejemplos. La que dice área del original multiplicado por el scale factor cuadrado. So, 25 va primero, 3 va segundo, que es cuadrado. Lo pongo en mi calculadora y me dio 225 pulgadas cuadradas. Ok, ustedes van a practicar en su computadora en una actividad. Traten lo mejor que puedan. Buena suerte.